Hello everyone. Today we are going through the contents of week 3 in quite a bit of detail, and this week starts with the topic of quadratic functions. But before going to that, since we are going a bit in a detail so that there would be no confusions after watching the videos of IIT Madras, so we'll start with revising certain concepts and then we'll be diving into these concepts or the core concepts of quadratic functions, right? So let's start. Let's first have a look to the flowchart, how we will be proceeding in this video. So since this topic states that it's a kind of function, so we'll first try to understand what a function is and some other prerequisites, right? Prerequisites, okay. And then we will start this quadratic function, and in this topic we'll be spending some time and we'll see its definition, its graph, and how to plot it, some terminologies and other things, right? Then the last thing, and the slope and all those things, that slope and all those things, right? So these would be covered, right? And then we will be diving into the concept of quadratic equations, right? Quadratic equations. And then quadratic equations. After quadratic equations, the last thing left is to solve them, right? Equations are to be solved, any problem is to be solved, right? So quadratic equation, and we'll solve them using methods such as factorization, the quadratic formula, which is also known as the Sridharacharya formula, right? And then we'll go with this completing the square method, and yeah, and graphical solution, right? Graphical solution and all those things, right? So let's start because so this would be our flow chart, and we'll be going through this we'll be following this pattern and proceeding, and we'll do questions also, right? Okay, so let's start. So what are functions, right? We have studied in a great detail that what functions are, and we will be studying uh, in the previous weeks we have studied what functions are, and we'll be studying them also in the upcoming weeks, right? The weeks after, fourth week and all those things, right? So what a function is: so if there are two sets A and B, and there exists, see, this reverse E sign is denotes the word there exists, right? And there exists a rule F that maps each and every element in set A with a, a, a unique element in set B, then the rule is said to be the function, right? Denoted as f A to B, right? This is the denotion, and this is the kind of basic but the actual definition of a function, right? So what does it says? It says that if there are two sets, right? So if we are dealing with function and all those kind of things, relation functions, all those things, the concept and the basic requirement of set theory is very important. And if there are two sets A and B and there exists a rule F, right, let me enclose this F in quotes, there exists a rule F that maps each and every element. See, this point is very important, this point, that each and every element, right? Because if this thing is violated, the rule is not a function, right? It may be something else, but it can't be a function. So this is very important. Each and every element in set A with a unique element in set B, then the rule is said to be the function. Okay, and this function from A to B is denoted as function from A to B, right? This arrow shows that elements of A are being mapped with elements of B, right? And what is the key thing to remember, that each and every element of A has to be mapped with some element of B, right? If each and every element of A is mapped with all the elements of B, then it's also a function, but it would be a different kind of function. It would be a function, but that would be a different topics of types of functions, right, which we are not exploring here. So yes, so what function are, let us take an example, graphical or figure like example, right? If there is a set A and there is a set B, and the set A has elements A1, A2, A3, A4, and the set B is having some elements of set like B1, B2, B3, B4 and B5, right? So what is happening here is, like let us associate or map these elements. This can be one mapping and there can be many mappings, right? So yeah, is this a function? And this is mapped with the rule F, let us say. So is this a function? Is this mapping a function? So yes, this mapping is a function because it is satisfying all the requirements of which are there, which are given in the definition, right? Each and every element of A is being mapped, like A1, A2, A3, A4, all the elements are being mapped with a unique element in B, right? So this thing is a function, and this B3 is left, but it's in B, actually it's in set B, so that's not a problem, right? Because this thing is regarded as what, codomain, right? So the A, the elements in set A are what, domain, right? Input values, and the elements in set B are known as codomain, right? Codomain. And those elements which are mapped with some elements in A, like B1, B2, B4 and B5, this set is known as the range, right? Range is what? Range is a set of B1, B2, right? B2, B4 and B5. So this is the range, and range is the subset of codomain, right? Range and codomain are different things, and range is a subset of codomain, right? So this is the basic definition and all those things regarding the terminology function, right, which is very important as we proceed in this course and in any of the mathematics course which you may encounter in your life, right? So let's move ahead. Yeah, and I would recommend that you should be knowing and you should know a little bit of calculus also, right? Calculus, those who don't know it, it's okay, because uh, because it's not necessary if you haven't studied calculus till now, but simple calculus like differentiation is required. Differentiation would become quite handy, right, in in the content of week 3, though it is not there in the videos of IIT Madras, but still I would recommend that if you have the knowledge of differentiation, then it would become, and you can take that difficulty and make it a cakewalk, right? So I think, yeah, the prerequisites are done. And if you want me to tell again what this inverse E was, so I would tell you again that this sign represent there exist, right? Let me write it here. This inverse E is denotes there exists, and if we write like this, it means there does not exist, right? And this reverse A is denotes for all, right? And this, you know, belongs to, yeah. So let's move ahead. So functions are of, you know, a lot of type on the basis of their behavior, right? So if we don't, you know, go in this, in the characterization related to the mapping, type of mapping which a function has, if we talk about the types of a function with respect to the behavior, right, and their composition, I would say, then there are many types of functions, right? So they can be, you know, algebraic functions, right? Algebraic functions. And in this also, if we refine and put some conditions on, then these algebraic functions become polynomial functions, right? These polynomial functions are subject to some restrictions which the algebraic function may or may not have, right? So polynomial functions are quite different, but they are kind of, we can say, related, or I would just say that algebraic functions are kind of parent functions of polynomial functions. Polynomial just functions are just different kind of algebraic functions, right? And there exist transcendental functions, you know, like logarithm, and there are logarithmic functions, logarithmic functions which have logarithmic, you know, expressions, right? And exponential functions which are often regarded as uh, transcendental functions and all. And the main important points I'm writing is piecewise functions. Piecewise functions which are defined piecewise, right? If there is a function fx which is defined like this, like it's x square until it like from minus, if x is greater than minus infinity to 0 or equal, and if its x is greater than 0 to infinity, right? So like this, if they are defined through some pieces, then it would be regarded as what? Piecewise functions. And what piecewise functions are? Some of the major and remarkable piecewise functions are, I would say, the greatest integer function, the lowest integer function, and all those functions, right? Yeah. So let's move ahead, and let's try to, you know, introduce the concepts of quadratic. See, quadratic in any sort of mathematics, or, you know, in any level of mathematics, means something which has to be which is having some degree of 2, right? So if in a function the highest degree of x is 2, then that kind of functions are regarded as quadratic function, though this definition is not that appropriate, and we'll be seeing what an appropriate definition, how an appropriate definition looks like, right? So yeah, quadratic function are a kind of algebraic functions, and if we talk more precisely, they are polynomial functions, right? So let me define them. functions of the form, or we can say functions of the form fx is equal to ax squared plus bx plus c, right, where a is not equal to 0 are known as quadratic functions, right? So you can see that in this fx, the highest degree or the highest power of x is 2, right? So that's why, and this 2 in the Latin, or I don't know, it's either Latin or Greek, quadratum or something like that, it means that 2, right? Something which is 2. So the degree here is 2, that's why this function is regarded as what? Quadratic functions, right? So let me write this function once again here, ax square plus bx plus c, right? And there is a very important condition again here, which is this: a is not equal to 0. Why this condition has been put up? This condition is here because this is the major condition due to which this function may or would not lose its quadratic form, right? What happens if a is equal to 0? Then this term would vanish, right? This would become 0, and we are left with just this bx plus c, which is a linear function, right? It has a degree 1. So that's why, in order to just make it or just keep it a quadratic one, right, we give it a condition that that the value of a should not be equal to 0, right? The condition is a should not be equal to 0, and there is one more condition which we'll be studying when we'll see the vertex, right? So what would be the vertex of the graph? Then we will have a in our denominator, and if it becomes 0, then the denominator will become 0, and it would create a lot of trouble for us. So that's also a reason which we'll be seeing later, right? So fx is what? Fx is ax square plus bx plus c. So there are it is made of some components. So this is the quadratic term, right? Quadratic term. It has the degree 2, that's why it is regarded as the quadratic term. This term is the linear one, linear term, right? And this is the constant term. Very nice. So these quadratic functions are actually made up of 3 terms. The first one is the quadratic term, second one is the linear term with degree 1, and the constant term with degree 0, right? In this is a constant term, so its degree is 0, right? So yeah, so let's take an example like this, some function gx which is equal to x square, right? This function is gx is equal to x square. So this function is a case, let us compare these two things, right? Let us compare. If we compare, then what we'll get that in this a is equal to 1, b is equal to 0, and c is equal to 0. So gx we can write again in this form of fx, 1 into x square plus 0 into x plus 0, right? So this gx can also be written in this form, which is nothing but an unnecessarily extended form, in order to just explain you that these two forms are the same and the ABC are the coefficients are different, right? So this is an example. Let us again take one more example of px is equal to some function. Px is like this. 3x square plus 4x plus 12, right, like this. So let us again try to compare the fx and this px. Then we'll get a is equal to 3, b is equal to 4, and c is equal to 12, right? So these things are known as quadratic functions, and they are quite simple, that any function of the form this ax square plus bx plus c, where a is not equal to 0, is regarded as a quadratic function, right? So let's move ahead and try to think that how to plot a graph of a function. So in order to tell how to graph a quadratic function, I have to first tell that how to graph a function, right? Or this is also a kind of prerequisite which I forgot, but let's think, let's ponder upon it. So if fx is equal to some function, right? So there is some function. So this we can consider a function as a machine, right, in which we give some input and we get some output, right? So we give input in the form of x, right? If this function is px or fx, so we give the output in the form of x, and we get the, or this, let us erase this, and then we get the output as f of x, that this machine molds it, or I can say that it makes the input into some other form. Like if if the function is a juice maker, then if you give apple, it would give you an apple juice. If you give it a mango, then you will get a mango juice, like that, right? So all those inputs are actually contained in the x-axis of the graph, right? So if we have to plot a function fx, then all the inputs which we'll put in this function, or the domain of the function, is in the x-axis, right? X-axis contains the inputs or the domain, right? And the values which the function takes, or the function gives out to you, are contained in the y-axis, right? Which those values are known as, we know, range, right? So let us try to plot a very simple graph, a very simple quadratic function, I would say, and this is the simplest one, which is fx is equal to x square, right? Try to fx is equal to x square. So the first thing which we can do here is that this function can extend up to infinity, right? Its values, its range, and its domain also is extending towards the real, all the real line, right? So we won't take that much of graph, and we'll just try to plot its trend and just get an intuition how the graph would look like, right? So yeah, let us try to make a table in which we'll put some x, values of x, and we'll get some fx, right? Let us take 3 or 4 values. What if we put -2? We get 4. We put -1, we get 1. We put 0, we get 0. We put 1, we get 1. We put 2, we get 4, right? Like this. Yeah, before moving ahead, we first should be knowing, and we should confirm on the fact that this fx is a quadratic function, right? We have discussed here that why this x square is a quadratic function, because it matches with the general form of quadratic function, right? So yeah, let's plot it. Right, so let's try to plot. This won't be an that good as you would get from a software, but let's try. This is the x-axis and this is the y-axis. 1 1 2, and there is a -2, and let us make the scale on the y-axis a bit smaller, because it's taking up quite a big and this is y is equal to, right, we can write y is equal to, because all the fx values are the output values. So this is 1, this is 2, this is 3, and this is 4, right? So if we are putting 1, we are getting 1. First of all, let's start from 0, right? If we are putting 0, we are getting 0. We are putting 0, we are getting 0. We are putting 1, we are getting 1, right? And if we are putting -1, then again we are getting 1, right? If we are putting -2, then we are getting 4, and if we are putting 2, then again we are getting 4, right? So we got a rough idea how the graph would look like. So let's just trace it with the help of the points which we got, and we get a graph like this, right? It would go on from this and this sides, because we have restricted our domain for plotting this graph till 2 and -2, in between 2 and -2, right? So it will go on because the domain is actually the whole real line, so it would go on and extend up to infinity. So just we have made a a little graph of it. So as you can observe, this figure obtained is known as, it's a kind of peculiar kind of figure, and this figure is actually known as the parabola, right? It's a parabola, and it's a matter of great research and studies in mathematics. So this kind of functions, this or this, right, both can be there. This can be an upward parabola or a downward parabola. Left and right parabolas, which some of you may have studied, will not be considered in this course, right? Because they have y square in it, and they violate the vertical line test of a function, which you will study later, right? So the upward and downward parabolas are the only graphs possible for the quadratic function, right? So we studied what quadratic functions are and how to plot them in graphical manner. So a quadratic function, if we plot them in the form of a graph, they just give a parabola, right? So point to ponder that graph of a of any quadratic function is a parabola, right? So graph of any quadratic function is a parabola. More specifically, if I have to say, then it would be either an upward parabola or a downward parabola, right? In what case this would become a downward parabola, right? So in this case, we can see that the coefficients, if we talk about this function fx, then fx is equal to x square, then the coefficient of x square, which is a, which we have taken in our general form, is 1 actually, right? And b is equal to c is equal to 0, right? That's okay. But let's try to understand how we can invert this parabola, right? This parabola is actually pointing upwards, or it's open upwards. Let's do some sort of clever tricks to make it open, or let's just try to invert it, right? How to do that? To perform that kind of thing, we just need to uh, do something, right? We have to apply some brain, and let us try to plot this. Px is equal to minus of x square, right? So let's again make a table and again take 4 values, right? X, we are putting x, and here we are having px, not fx, because this function has been changed. And we'll take again 4 values, 5 values, right? Yeah, and let us again just for a minute, let's discuss this function px. In this function, a is equal to -1 and again b is equal to c is equal to 0, right? So we are now focusing about the coefficient and their effects upon the graph, right? So I will explain it in a general manner, but let's just first develop a kind of research kind of sense in our mind, right? And proceed in a, how a scientist proceed by some sort of taking some observations and then putting them systematically putting them in the conditions and then move ahead, right? So what if we put -2? We would have got 4, but here the minus is also minus is altering our observations and we'll get minus, right? If we put -1 we get minus. If we put 0 we get 0. We put 1 we get -1. We put 2 we get -4, right? So you might have got what I wanted to tell you in this condition, right? So again we are taking this and let us announce these two axes as x and y, and this point is 0, 1, 2, 3, -1, -2 and -3. This is, let us say, -1, -2, -3, -4, right? We won't be needing this upward y, so I'm not going to write the numbers there. So what had happened to our observation table? If we have put at 0 and we have got 0 right here, and if we put 1 we got -1, right? We put -1 or 1 we get -1, right, like this. Okay, and if we put 2 or -2 we got 4, -4, right? So like this and this. Yes, now let's trace it and get our parabola. I just missed it, sorry. Yeah, something like that. Again it's a bit of bad, but yes, like this, right? So what we have done here, it's a kind of magic, or it's a kind of beauty of mathematics, that we have inverted this graph, right? We've inverted this graph and just made it, inverted and made it opposite about the point, about the axis x. So you might have got some of the intuitions that what is going on in particular these particular examples. If not, I'll tell, of course, right? So let's try to again analyze this, our first graph which we made, like this. I'm just making a rough graph, right, this time, because now we are just observe. Yeah, something like this was the graph. Now if you have a software known as Desmos in your phone or laptop, you just go into that, or GeoGebra or anything, and just type this function as x square and you'll get a graph like this, right? So you'll observe that this y-axis is actually an axis of symmetry, right? If we just erase this, if we just erase this, right, in that graph, this is not an actual graph, right? So, and just, if we have some kind of ink paper and just folded it through y-axis, then what we have got, its other part, which is like this, right? So the y-axis here is what is actually the axis of symmetry, and all the parabolas have an axis of symmetry, and this axis of symmetry is at it passes through the vertex. And let me, if I have said the word vertex, then let me introduce that what a vertex is. So yeah, if this, see this is the line of symmetry, this y-axis, right? The point where it meets with the parabola, right, and that point would be regarded as the vertex of the parabola, right? That point would be regarded as the vertex of that parabola, right?